Yesterday I posted on Slack that I thought of a couple things over the last few days, and one of them was to get the steering to work on a vehicle. And the concept is what people have done so far. They've taken power steering motors and bolted them to their lawn tractor, and then hooked that up to an Arduino type processor and a feedback pot, and basically made an RC servo, made this giant steering motor into an RC servo, except that you can set an actual command. You can say set to this angle instead of using the RC control pulses. And it can be a little tricky trying to adjust all that and get your software right. And then I kept thinking that I've seen where people will take a big motor and take an RC servo apart. Just one of the standard. I don't have one laying here, but just one of the little RC servos. You rip it apart and take the control board out and hook it up to a power driver and make your own RC servo. So now it's going to act just like a regular RC servo. You send it the control pulses, and everybody should be happy on that to make it work. So I was doing some digging, and I'll post this to chat. Here's a couple links. Now, the one that says the link where it says using Arduino. Let's see, how can I get that to show up on the screen? Here, let's do this. I realize now if I put it in chat, I can't display that. So let me say, put that there. Let me say, do this here, and untitled notepad. So assuming that shows up, there's the links to it. So the one that says using Arduino is that's by a guy named James Bruton, and he does all kinds of interesting stuff. You might want to dig through his webpage if you got nothing else better to do. But basically, he's took a windshield wiper motor, and he did some 3D printed brackets on the thing. So he put a pot onto his motor, and then has like a control arm sticking out, and he connect that to an Arduino Uno, and then he shows you the code he's running to make that work. And I don't remember what his communication was, if he's saying go to this angle or how that was working, but he had a way to control that. And then another guy was saying, well, he wanted to build one doing it this other way, just using the RC control board. So the one that says using RC servo on that link there, that one is basically he just took an RC servo, or he took a windshield wiper motor and hooked up a pot somehow on it, and then used the control board out of the RC servo and got a power driver module and just wired all that stuff together. And now he can feed in RC control pulses and make the motor go to the position he wants. And the discussion that was there, because he was talking to this other guy that used the Arduino. So it was, as the guy with the Arduino pointed out, you got much better control over how you get the thing to control. You can adjust the PID parameters because you're doing all that yourself. And they were saying, but if you build one just out of an RC servo, it may have been adapted for the size motor it was or whatever, so it may not work as well. So the guy said, well, I'm going to go ahead and do it anyway. So he built the thing and put it together. And at the very end, you can see he's moving he had a radio control transmitter. He's moving that. The thing would move back and forth. And he said, well, it's got more jitter to it, or I can't remember. Because it wasn't quite as stable as it could be. And by watching this video, I finally decided, well, I can't tell by doing that. So I figured I should go try that myself and see what happens. If I take a windshield wiper motor or take one of the full power steering motors and do exactly the same thing to that. So it's the motor, and you got to put a pot on it. You got to have the big power driver module and some scrap RC servo board. And then if that works, then you can talk to it just like an RC servo. So you've got, generate the pulse width, just a second, generate the pulse width, 1 to 2 millisecond pulse width, and that should control the thing. Okay, what's your question? You're just waving
Well, I
at me.
was wondering, we've been using these Citron motor controllers, which, sort of serves to a purpose, but one of them is to provide the power. And I think I've got a 20 amp circuit in my power to that. And I can watch the videos, but I was just wondering what they were using for power control.
You mean the motor driver, the actual thing that converts the logic level into the high current? Is that what you're asking?
Less digital and more analog. I mean, I've got a 12-volt molder and a 12-volt battery, and there's this power supply that sits in the middle that, I mean, inexpensive motor drivers can handle 5 amps, more expensive ones can handle 20 amps. What are they using?
Well, so since you're talking about the power driver that goes between your battery and your motor, it's controlled by logic. Uh, they're not using the Citron board because it uses a pulse width pin and a direction pin into it. And the servo puts out basically what they've done, they just taken the two wires from the motor and connected them to the logic lines. And you're not, it thinks there's a motor out there, but there's not. And you have to get a driver board that will accept one that has a forward enable pin and a reverse enable pin. And if you have that, then you can just wire that up directly and make that work. So there's a couple of different boards. Let's see, of course, I don't have that right here in front of me. But yeah, you have to get a board that's got that concept. So like the old 298 L298 probably has that kind of interface, but don't buy those because they're old and they're not MOSFET, and they're only good for 2 amps or something. So I've seen them use two different boards here. One that they claim is a 50 amp driver board, and it was around, when I was looking on Amazon, they're anywhere from like the cheapest I could find is like $10 for one of those. And then I can get the other brand, the other model that's got a big heat sink on the back and then two of these driver chips on the top. And that one, I think they say it's 30 amps continuous and like 43 amps intermittent. It's a surge of like 43 amps before it burns up. And that one, I bought 4 of them, and they're $5.50 a piece if you get those. So it's just a matter of the reason why I don't use one of the Citron boards is because the logic control pins aren't in the configuration that I want. I could probably pull out my box of logic and fake it out to make that work. But I thought, well, I went and watched these videos on YouTube, and they're using one of these two different driver modules, and I just picked one that I looked through. There's enough people using this, so I'm sure this will work. So I ordered this up to go try that. And let's see. So if you watch those videos, they'll tell you which ones they used. And I guess if I look here, I could probably come up. Let's see.
I mean, you can fire up the video. We can watch it now.
Well, they're kind of, well, let's start with one, and using the RC servo. Hold this up here, and don't panic yet. I haven't turned it on. Okay, so if I do this and say this, where's my thing here? So I'm assuming, okay, I'm assuming you can read that. Let's go down here and see if he tells in here.
Yes, I can see it.
Checking, blah, 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 blah. I thought he would just have a list down here. It says, here's the part that I used. And we'll just run a little bit of this so you can see what's going on here. And you won't get any audio on this because I don't know how to turn the audio on. And if there's any music in the background, then they get cranky about it. So actually the board he's got here is not the board that I got. I got the other one, I guess. But this one has a heat sink on top of the board, but it works the same way. And the other one has the heat sink underneath the board. So let me just run a little bit of this. And as I say, you can't hear what he's saying, so this isn't going to do us any good. Now I think about this. So let me stop this and go find. Let me just pull up something like, how do we get a browser here?
I was just curious about the motor driver. What how they were integrating the motor driver and the potentiometer. But more about the motor driver, because
Well,
those are the
the potentiometer goes right to the RC servo board. So you tear the servo apart and you take the board out and you hook your pot up where the pot is normally on that board. So that's how that works. And then just they take the two motor leads to drive a big driver module. is what they're doing. Let's see. Let me do this. Let me see if I can sign out. Let's see. Hello, sign in. Okay, so I'm not signed in. Let me say, this will show me. Okay, so let me see. How do I get my stuff back? I'm down here, share screen. Do this one. Okay, play the game. Okay. Assuming you can see my screen there.
I see some motor drivers.
So I bought this one that's on the top here. It's a BTS 7960. They say it's 43 amps, high power. And if you look harder, it says it's like continuous is like 30 amps and surge is 43 amps. And here's the L298. It's got essentially the same kind of interface, but I would say don't buy those. And where's the one? This one, let's see. This top one, that's one I actually ordered. They're supposed to show up tomorrow. And then here's the same ones from a different angle. If we take a look at them here. So it basically just has, it's got like these control pins here. Now I can't go point to them because then I'll lose my. So in the middle of the board, it's got those stake pins on the right hand side of the board there, and it's got like a forward enable or reverse enable, and I think you might be able to read the current out of that. I don't remember how that works, but anyway, that's one of them. You just take this board, you hook your the big green connector there. You put your battery power in, you hook your motor up there, and then you put your two logic control lines, and you might have to put 5 volts into the board, and you probably need a common ground between the two. And then the other one he was just looking at. And I thought if I order 4 of those, I can get them for $5.50 a piece. So that's what I ended up doing. Now, of course, they're not going to show me that other one.
Sweet. I mean, 43 amps, 20 continuous. I definitely think that would be enough for.
So this is the other module that's basically does the same thing, and they say it's 50 amps, and I assume that's continuous. Again, you got to read through their fine print to see what it says. And keep in mind, they might be lying to you also. It could be that it's, good for 20 amps, but they say it's 50 amps, and they just don't bother to tell you the right thing. But this is just basically, this works the same way. You've got the two the green connector out there, you put in battery power and hook up your motor, and then over on the right, it's only got what, 3 pins?
Now
So
I
it's
only
got
see
ground,
3.
it's got N1 and N2. So they take the 2 motor leads coming out the RC servo and plug them into the N1 and N2, and you just hook up a ground between the two to a common ground. So this one, when I dug for these, I couldn't find them any cheaper than like $10 a piece or something, no matter how I bought them. So I ended up buying that other one to try it out. So when those show up, I'll go ahead and try that. And if you go to watch the videos, if you just search for giant RC servo, or say windshield wiper motor RC servo or something like that, there's lots of people doing this. They all start off and say, oh, when I looked this, I couldn't find any information, but here I just slap this stuff together and it works. So it's, everybody's copying everybody else and claiming that they're the ones that created it, I guess. So anyway, and now I was having so much hard time finding it. Well, down here, here's this one that I didn't buy, and right next to it is the one that I did buy. And they're saying here's all the L298s, which again, don't buy those, but they're saying you can get those. So that's where that comes from. And then you're asking about the pot. Well, the pot goes to the RC servo board, and that just works like a regular RC servo does. So it's just a few parts connected together should make this work. And then the question is, how well is it going to work? Is it going to give you a stable output? Will it go to the right position? Will it hold that position, and so forth? So that's just something that somebody's going to have to try it and decide if that's going to work or not. So,
And then what did they do creatively to? I mean, they need to get actual angle. I mean, on that RC servo board, there's a potentiometer, a physical deal, right? How
Yes.
did they connect the windshield wiper up to that in order to get the actual angle?
Well, the same way you hook a pot up to your power steering motor, you just take it and you hook it to the shaft and you've got it set. So it works just like an RC servo. The RC servo has a pot on the back of that. Got that thing sticking out. Got that control shaft sticking out. Oh, I know I got some laying here somewhere, but of
It's just
course
always some
I can't
interesting
find it.
mechanical engineering jiggery pokery to get those connected.
So if you look at the various videos that are out there, everybody does a little bit differently. Some people just actually leave they open the case and they pull the motor and the gears out. That leaves the shaft sticking up. It's still got the pot on the thing. So then they can just put regular RC servo arms onto that. So some of the people have um, in fact, that one I just looked at, I think he did it that way. The windshield wiper motor has an arm sticking out already, and he's got the arm sticking out RC servo. He just puts a little connecting link between those two. So as you move the arm back and forth, that's what controls the thing. And if you want to, you can just stick a motor right on the end of or stick a pot right on the end of your motor shaft and do it the same way, probably the same way you're doing right now on your motor you're controlling.
Yeah, I've actually tried two things at the moment. It's the 10 turn pot is down at I'll call it the half moon gear. And then the other approach, and I consider that to be sort of low resolution. The other approach was that I slid a gear over the motor shaft and then effectively connected that gear to the magnetic rotation sensor and got the actual angle off of that, which was higher resolution, but it sort of stuck out like a blob on the motor. And since the 10 turn pot seemed to be doing fine, at the moment, that's what I've got.
Well, I thought you were asking, well, how do you know what angle the thing is at? And the answer to that is it works just like an RC servo. You hook up an RC servo, you give it a 1 to 2 millisecond pulse width, and it goes from typically they'll have like either 180 degrees of travel or 270 degrees of travel. And it's up to you to figure out, what pulse width to set it to what angle. So you would have that same situation if you build a giant one of these. That's exactly the way it would work there too. So it just first of all, we just need to decide, can you adequately control a big motor like that and not have it do anything stupid to you? And that, once we figure that out, then we can decide, does anybody want to move forward with actually trying to do this or not? So let's see, that was the one thing I mentioned, that possibly you could make it into an RC servo, and that may or may not be of benefit to people. It does probably add more steps of, conversions and scaling and stuff in between. So that may not be the answer. Although on my Sammy 2 that just has an RC servo, I seem to be able to, it seems like I can adequately control that by just saying I want it to turn this far, so I give it this pulse width, and that seems to be working, even though I need to go out and prove that works under all conditions or whatever. So what was the other thing I mentioned? Oh, any more questions on that?
Simulating. No, I'm good. I watch the videos.
Okay. And as I said, there's tons of videos out there. You can go watch other people doing it, and they've got different ways of connecting things together, and they probably have different power modules they're using too. So that just by watching a bunch of different ones, you can see what people are doing and see if they have any comments on does it work well or not work well. So that's something, if you've got extra time, you can waste a lot of time doing that. So the other thing I'd mentioned was, it occurs to me that you showed a video where you took you were running you had the simulator loaded up, and you said your tractor was sitting by your garage, and you said go, and it drove across your yard to the starting point of your path that you had created with that create path program. The thing would lock on, it would drive around there and follow the path, and that all seemed to be working. And then you said now you took out your physical lawn tractor, put it out in your yard, and you basically did the same thing. You put a different path in there and you weren't displaying the path. So we don't know what the path looked like or if it was in the right spot or the right angle or whatever. But anyway, you said the thing drove over to the starting point and it seemed to be driving it at an odd angle from where I thought it should be going. When it got to the top, instead of turning to the left, it actually turned to the right and drove off into the weeds. So I was thinking if you just go in your garage and turn on the power on your lawn tractor. Before you do that, we'll say what you're going to do is you're going to take your laptop, you're going to fire up the simulator and put in a path and prove that, you know, the thing will go drive on the path like it's supposed to. Then uh, fire up your lawn tractor and tell the steering on that to subscribe to whatever commands that this, you know, because the simulator is generating a like a command velocity or Ackerman command or something. It's generating a signal that tells the your pure pursuit is telling the simulator where it wants it to go. So it's saying drive forward this speed and turn the wheels at this angle, and that's what makes it drive around on that path. So just while it's doing that, if you have your lawn tractor have the steering function subscribed to that command, you can now watch the wheels on your lawn tractor. So is it, you know, just sitting there in your garage, not moving, when you fire up the simulator and it starts driving forward, your wheels on your lawn tractor should be in the middle. And if it starts turning to the right, you should see the wheels on your lawn tractor turn to the right. And when it turns to the left, you should see them turn to the left. And just by watching it, you can tell approximately, is the scaling approximately right? Is it turning the right direction? There's lots of things you can tell about that. And for instance, you put the laptop behind your lawn tractor, so you've got the same perspective. So go into RViz and say, I think you can do this. Go into RViz and go to the camera and say, I want to have a camera from the back looking down towards the front of the lawn tractor. So you got your simulated lawn tractor. And if you can get the RViz to do that, you should be able to see the path on the ground that you're supposed to be following. You should see the two wheels on the front of your simulated lawn tractors and move back and forth like this. And then you look beyond your laptop and you can see your actual physical wheels on your lawn tractor. And so back here, you can see here's the simulated one. You can see the wheels doing this. And up here on the lawn tractor, you can see the wheels and see if they're following the same thing. So that would be without having to drag it out in the yard, without having to worry about running over anybody or getting away from you. It can just sit there on the ground and it just, all you gotta do is power up the steering and watch the steering to see if it's following what it's supposed to be doing there. So at that point, the simulator's in full control and you can see it's doing what it's supposed to because it's out there following a path around. So I think that would be a handy thing to be able to do that.
Yeah, I agree wholeheartedly. I think to be able to confirm, right, pure pursuit's going to spit out a command velocity angular Z. Yeah, linear X and angular Z, or the reverse. Anyway, yeah, I think that would be great to certainly you'd at least be confirming the low-level controller can read a command velocity statement and turn the wheels basically in the direction that you wanted to. That would have, my past complaining about weather and raining and all that other stuff would have at least been able to test half of it.
And
I mean,
another thing I've noticed on that is if you like that particular case where you had the lawn tractor by the garage and you got a path defined out in the middle of the yard, you turn it on, it's not, your pure pursuit is not controlling it at that point, but somehow it magically is able to turn in the right direction and drive over to where the path starts and turn onto the path. So keep in mind at that point, you don't have the same constraints on your steering angle that you have once the pure pursuit starts. Because on pure pursuit, it's going to follow whatever list of points you put in that path that you created. And you created that path by going back to that generate points or whatever that program is called. And there you specify what's my turning radius. So when it generates, say you got the thing is driving up like this and gets to the top and then wants to go around the circle here, by specifying the radius, that tells how big to make that circle. So when it's running under control of pure pursuit, you're either going straight forward or you're turning to the right or the left at that angle that you've specified. But until it gets over to the point and starts controlling, So coming out of your garage, it's just going to say, oh, let me just cram over as hard as I can to the right and try to go in that direction. So that may be giving you much sharper angles than what you would be expecting. Once it's under control of pure pursuit, then it's going to spit out the angle that you told it when you generated the path. But just driving before you get there, you don't know. I don't know what's specifying that. If it just simply tries to crank it as far to the right as it can, and then it's up to you to limit that to make sure your steering doesn't go too far. So that's just something to consider on that too. So even if it's just sitting there on your garage floor, like I just mentioned, it could still try to turn it too far because number one, the simulator doesn't know your lawn tractor is hooked up. It just says I'm talking to it says I'm talking to this vehicle in the world, which happens to be a simulated vehicle, but you're just in parallel. You're telling your steering on your lawn tractor to follow that. So you still have to be careful. You don't, give it too big a value and destroy anything on the mechanical part of your lawn tractor.
Yeah, I see a lot of benefits to using that for testing. That's a great idea.
And if you wanted to, at that point, if you fire up the transmission control, that should also, if it says start driving forward, you should see your transmission lever should go forward and to whatever. It doesn't do a whole lot of good because with the engine's not running and with it not driving around, that didn't really tell you anything other than you can see that, the transmission is trying to respond to whatever speed that Pure Pursuit's telling it. And I'm thinking that Pure Pursuit only puts out 0 or whatever you told that you want the maximum speed to be. So I don't think it's doing any extra controlling between there. So I don't know if you really want to waste any time other than you could just prove that works. But beyond that, I don't think it's going to tell you a whole lot at that point.
Great suggestions.
And if you do this, don't fire up everything on one track. You don't want to be publishing odometry. You don't want to be doing all this other stuff. You just want to have, say, a node, drop it into your simulator code, put a node that says subscribe to your whatever, whether you're using command velocity or Ackerman command, and just talk directly to your steering controller. So your steering controller is basically just subscribing to that. And you don't want to publish a lot of other stuff because the simulator must be in control. You can't have anything on the lawn tractor publishing because that would just confuse everybody if you try to do that.
Yeah, as you were talking, I was thinking I would basically update the firmware on the ESP32 to be purely just listen for command velocity and drive the steering motor control.
Do you have a separate controller on your steering right now, or is it you just have the main ESP32 is controlling everything at this point? At one point you had a separate, like a Teensy or something on your steering. Is that still there, or did you take that out?
Well, let me describe it. The 10-turn pot that gets the actual steer angle is physically wired into the ESP32. And so the ESP32 is, the low level controller that's taking that actual angle and then doing the ciphering and then sending messages to the Citron, which is also physically wired into the ESP32.
Okay. Now you may not have to make a lot of modifications. The only thing is if you're not sending out um if you're using command velocity, if you're not publishing that at a constant rate, and you've got something at ESP32 that says, oh, I haven't received that for half a second or 1 second, and it tries to shut everything down, that might get in your way. But once you start up Pure Pursuit, it starts publishing, whether it's putting out a speed and steering of 0 or something else, it's constantly publishing. So you probably wouldn't have to change. And maybe I'm wrong here, but you probably don't have to change anything on the ESP32 as long as it is subscribing to your command velocity coming in. I think it will work. It's just that you don't want to publish that stuff back to the ROS world. You don't want to have like odometry and all that other stuff publishing back because that would just confuse everybody if you do that.
Yeah, I've got I found out the hard way, some safety switches in there that keep it from driving if it's not getting RTK fix. I think it shuts down. Not shuts down, it doesn't turn the motor off, but it says, hey, I don't know where I'm at. So I'm just going to send neutral to the transmission and straight to the steering. So it certainly can. Again, bottom line is it's a great suggestion. I got to get into the practicalities of how to steal that command velocity data from the simulator and just use that to steer. I think it's a great idea.
You could even just modify a node that would run on the simulator computer. Originally you're using ROS Serial. Did you change that to something else now? So and no, whichever one you're using, if you wrote your own code, it just write a node that says subscribe to your command velocity and push that out the USB down to your ESP32, and that's probably, just send out the command velocity down to it, and that should keep it happy. That avoids all the other stuff that's going on then at that point.
Can I share?
Sure.
Speaking of ROS Serial, my bane of my existence. Come on. So this is a, I'll zoom in here, but just to give you a sense, each of the, we just moved something, didn't want to do that.
Well, Control Z, but put it back.
Yeah, this is a flippin' Apple product, and it doesn't. This is a product called Freeform, that little squiggly there, and I was struggling at getting my serial communication to work. No, now I know where I moved it from. Right there. So each one of these little yellow sticky deals is, some sort of software component of all of the stuff that I'm dealing with. And these are some of the key ones that have been on my mind. So they're sort of at the top is the ROS master, which is running on the laptop. Over on the right is the ESP32. I happen to call it TTGO main. And at the moment, I'm trying to get data out of ROS master into that TTGO main on the right, and also get just some status data off of that ESP32 and back into the console, just so it can display it. And I've just making that happen is relatively easy. For some reason, though, when I try to do it on one channel, I'll say channel or port. Over here, I also have the LoRa network and ROS Serial running on that ESP32. I was not able to get that to work, so I abandoned that and wrote this serial program that just is trying to do it all over serial ports. So when you ask, am I using ROS Serial? The answer is yes. I have a left and right speed microcontroller that's got ROS Serial running to feed some data into the ROS master. And I would use ROS Serial exclusively, except it seemed to screw up my LoRa communications. And so that's what I have been and continue to struggle with. And the main change from this time a week ago is I gave up trying to do it on one port, and I added physically another USB to TTL device into my USB hub and physically connected that to the ESP32 and via USB cable to so it's a USB converter. One end is going into the USB hub, and the wires that come out of it go into the ESP32. And that's where I'm getting the command velocity and GPS status and speed parameters. And it's all one way because I was not able to get two-way communication going on that serial stuff. I mean, it's not a detailed explanation of the problems, but it's just sort of a high-level overview of where I'm at. And ROS Serial is used, but not exclusively for handling the communications between my boards. And how do you do this? Do you mind sharing?
How do I communicate from ROS down to my microcontroller?
Yeah, and more specifically, how do you get command velocity data off of the master and into your microcontroller? And do you get any, I'll call them debug messages off of the microcontroller back up to your console?
Well, I just have a connection. Let's see, make sure my audio is on here. I have a connection between my ROS computer and my microcontroller. And right now I'm using a USB cable between the two. So I've got, I just plug a USB into my ROS computer, which at the moment is a laptop. That technically there's a hub in there, but it comes down and plugs into a connector on my microcontroller board. And I can either use the debug connector that they gave me, or I can wire up an extra, like you just said, you put an extra USB to TTL adapter on there. So anyway, that gives me a communication link between the two. So at the ROS end, I just wrote a node that says, it's probably written in Python. I grabbed it from somebody else and hacked on it. It basically says subscribe to command velocity. So then in my code, it says, I just got a call back saying I received a command velocity from ROS. And then when I see that, I just strip off the forward velocity and the steering angle, and I just build up my own packet. So I was just looking at the code last night. I put the letter S for speed, then I've got a comma, then I put the forward velocity as a number, comma, and the steering angle as a number, and I just say print, and that sends that down to the microcontroller. So now the microcontroller says, oh, I just got a call back saying we received a message from the ROS computer. And it says, oh, well, look at the first character on the line. Is it S for speed, or is it, I can't even remember what the other ones are, but as I define different types of packets I want to send, I just put a different letter on the beginning of each one. So then down in the microcontroller, it says, oh, I just received a message. It says S on the front. So I'm going to assume it's going to have a forward velocity field and a steering angle field. I just strip those numbers off, and I can do whatever I want with those at that point. And then going the other direction, it's just basically works the same way. It's just like, say, for instance, my odometry is running in the background. It's generating all the values I need for that. So it says, okay, I've now got all the data I need. So it builds up a command line. I think it's O for odometry, comma, X, comma, Y, comma, theta, comma, forward velocity, comma, rotational velocity, or whatever the command is. I take all the numbers I need. I think since this is my own format, I just tack some extra debug stuff on. I think I said, here's the left wheel encoder and here's the right wheel encoder. And I take that whole string of stuff and I just say print, and that sends it up to the ROS node. The ROS node says, oh, I just got a call back saying we received a message from the microcontroller. And it looks at the first thing and says, oh, that's an odometry message. So I'll strip off the fields I want and build an odometry transform and an odometry topic, and it publishes both of those, and then everybody's happy. So if I want to send more data up, And you said debug stuff. Well, I can create any debug stuff I want on the microcontroller, and I just build up a command line and say maybe I'll put D for debug, comma, and then a whole bunch of numbers. And I just send that up to the I just do a print that sends it up to the ROS node. The ROS node says, oh, I received a line. Oh, it's D for debug. So I'm going to strip these values off and publish them any way I want at that point. Or it could be I'm just talking, one node is talking to the other, and I don't actually, I wouldn't have to actually publish that. That might be doing something in that particular ROS node on my ROS computer to, maybe it's changing scale factors or whatever. So I can go either direction, like in the ROS world, you send parameters to something. I could have a thing at the ROS level that says subscribe to, or it says grab this parameter, and I could shove that down the cable to my microcontroller, in which case they might be scale factors, or it might be limits for steering, or whatever they happen to be. Or it might say, one of the things I do is I send down status information, and then it goes out to my LED. I was gonna say that goes to my LED strip, but it doesn't work that way. That's got a separate cable that goes to my LED status. So, but anyway, that's the concept. You just on the ROS side, you subscribe to whatever message you want. I strip off the fields that I want, build my own message, and send it down. And the other side agrees that, oh, if it's it happens to be a speed command I just received, that it's going to have two fields, and here's the values. I do something with that.
Yeah, I finally got mine to work as well. This is what the code looks like. I mean, it's really similar to how you described. There's, my bespoke or private or proprietary. I did a 1 with the speed and blah blah blah, some other data. And so where I was at this morning was I was trying to get command velocity data down using a ROS topic pub, and I had my launch file had pure pursuit in it, and I didn't realize that pure pursuit, even if I'm not trying to use it, is jamming down a command velocity value of 0. I'm like, stop that. So I've been changing my launch file to take out pure pursuit and just to test that I can send command velocity, whether it's pure pursuit or not. But anyway, so that's where I'm at. Is got my serial communication working with a customized approach, and now in the process of trying to test that and having to come up with a launch file that's minus pure pursuit, at least for now, just to test things out. And I don't have my robot description. When Gazebo's not running, I don't get a complete robot description, so to decide whether I want to run Gazebo when I'm running in the real world, so there's a full robot description in Arvis or not. Probably I won't. I'll just have the transform, whatever you call those little icons, going. So that's where I'm at. But it was useful to stop and make this sort of flow diagram, although can't really get the darn thing off of it. It's an Apple thing, and it's only for Apple, and I think I'll have to now redo it again on some other platform that's a little bit more shareable.
Yeah, a while back when I was cleaning the stuff out, I ran across my Visio CD, and that's, I think, Visio 2003. So it's, that's quite old, but still, that's the only thing I have that I know enough about how to run. I can load it on my Windows computer here, and that I could go back to drawing diagrams. But I'm sure there's stuff for Linux you can run, but I have no idea what it is, and just yet another cryptic thing to learn. So I've just been avoiding the whole thing.
Yeah, I did it because I was getting confused about what was working and what wasn't, so I had to sort of stop and started with paper and pencil, and I'm like, oh my gosh, this is gonna need to move things around a bit, and so I reached for the first thing that worked.
You know, another way to do it, if you're doing it manually, get those little tiny post-it notes, the one they're like 1 inch square, and just take one of those to be a node and write on it what it is. That way you can just stick it down on the paper, and later you can pick it up and move that around. So that's better than having to erase the whole thing or cross everything out or start over every time you want to make a change. You can move those around and just draw lines in between for your arrows.
Yeah, so I did get I mean, to continue the story a little bit, I did get my tractor out in the yard and was driving around manually, and then had that simple path in there and turned it on and said, hey, to run the path, and it just sat there. Like it's not moving at all. And that led me to it wasn't getting GPS RTK, and I'm like, I've never had a problem with getting RTK fixed. And that led me to I had goofed up my udev rules and my port assignments and names, and so my GPS was trying to send data to the I don't know what was going on, but suffice it to say the GPS data wasn't on the right port and going to the right place, and or some other port was conflicting with it, and yeah, hence the reason for okay, I'm going to draw this out and make sure I got my udev rules and my ports and everything named correctly, and yeah, that was one of my oh shoot moments. It's all good. And so my udev rules, I'm just going to show you those because it ended up having to be which of these is the main? Oh, I'll just say this is the program that's reading and writing data from the serial port. And so these are examples of my messages coming back from the ESP32 and to the console, and the kind of stuff that I'm interested in lately has been, how fast is my LoRa running? It's running at 2 hertz, which is not going to set the world on fire, but it's livable. My radio signal with a whole bunch of interference are running around right in my garage is minus 66, which is good. I can keep track of how many loops the main loop on the ESP32 is running, because I want to make sure nothing's blocking that. I was having some issues with the other thing blocking code earlier. And I keep track of my is my LoRa running okay? Yes. Is my e-stop, what's my e-stop switch at? Is my command velocity frequency okay? Anyway, and so I'm sending data from the Python program on the laptop, and then able to get it back. So I'm all on one console, so I'm happy that I'm making some progress anyway. But I digress. I was going to show you my udev rules. Old, new. Was not able to I mean, these are, I don't know what you call these things, kernels. This is effectively the port that it's plugged into on my USB hub. I was not able to get that to work with the IMU or the USB to TTL board, but I just put the reference in there for chuckles. And then the others are physically, which, so if I ever move these, things would get screwed up, but I gotta leave those alone. But, yeah, that was getting my GPS and not having anything else conflict with that was why my tractor didn't move the last time I was out in the yard. Didn't have a good RTK signal. And now I'm just trying to do a little bit more testing before I go out in the yard, and the test you suggested is a good one. Okay, I'm going to stop blathering. I'm done. We can turn recording off.
Okay. Oh, hold on. I almost killed everything here.